All right, good morning, guys. So today we are going to talk about how we can tell if something is a proportion, and more importantly, how we solve a proportion, and of course, what a proportion is. So we'll quickly go over a little wrap up from our previous lesson, which was solving for a given variable. So solving for x, number one says x minus 3y equals 2. So if I want to solve for x, I need to isolate x. So I eliminate negative 3y by adding its opposite on both sides. And that gives me either x equals 2 plus 3y or 3y plus 2. For the second one, we have 5x. So if I want to just get it down to 1x, I'm going to divide both sides by 5. So I get x is equal to 13/5 y. The third one is two steps. So I have to isolate my x term. So I add negative 3 on both sides. And I'll bring this down here. So if I don't want 1/4 of x, if I just want x, I need to multiply by the reciprocal, which is 4. But on this side, when I multiply by 4, I need to make sure that I distribute, and that gives me x equals 4y minus 12. All right, so let's talk about a proportion. So a proportion, that's a tough one, is a pair of equivalent ratios. So if A divided by B is equal to C divided by D, right, we have two equivalent ratios, then our cross products are equal. And that is the most important part, and that's what's going to allow us to solve proportions if there's something missing. So some teachers will teach you something, they'll say, oh, it's like the butterfly method, okay? We're just cross multiplying, right? Cross products are equal, that's what we're talking about. Now, usually I do a little demonstration in class, right? Obviously this is remote, but I say, okay, give me as many fractions as we can that are equivalent to half. And someone will say 5/10. And I will write 5 halves, and then I will fix it and say 5/10. And someone else will say 2/4, and someone else will say 100 out of 200, and then we'll get some really big preposterous ones. But let's just look at what we have here. In all of these cases, right? 2 times 5 equals 1 times 10. 2 times 10 equals 5 times 4. 4 times 100 equals 2 times 200. The cross products are always going to be equal. And from a more fundamental perspective, because if we were treating, let's say, this as an equation with fractions, and we multiplied by the common denominator, which is BD, it would leave us with AD equals BC. Okay, and again, that's something that I've shown in class, and I don't think we necessarily need to talk about now. But this is the significant part here, that if you create as many equivalent fractions as you can, all the cross products will be equal. All right, so let's solve a few of these, right? So how would I solve my first one? Well, I know that 3 times x is equal to 7 times 15. So that means 3x is equal to 7 times 15, which is 105. And I get x is 35. And I could check it by cross multiplying. And of course, someone else is going to come in and they're going to say, but wait, you could have done it so much easier. You could have just realized that to get from 3 to 15, you multiply by 5. So to get from 7 to the equivalent denominator over there, you would multiply 7 by 5. And I'd say absolutely. All right, so there's multiple ways that we can solve our proportions. Okay, if you can identify a multiplier, whether it's an integer or a fraction, you can do it that way. But for the most part, I'm going to do these traditionally, and then I'll talk about some of the other strategies. All right, so let's talk about this one up here. Okay, so again, if I'm cross multiplying, I've got 10 times c is equal to 4 times 35. So I get 10c is equal to 140, so c is equal to 14. And if you wanted to use one of those more sophisticated strategies, to get from 10 to 35, you multiply by 3.5. So to get from 4 to c, we multiply 4 by 3.5, and that would give us 14 as well. All right, with this one here, we're going to do the same exact thing, right? I know that 6 times 20 must be equal to 8 times 2y, which means 120 is equal to 16y. And we're going to divide both sides by 16, which will give me y is equal to 15. And again, if you wanted to use one of those more elegant strategies here, to get from 8 to 20, you multiply by 2.5. And if I go ahead and I multiply 6 by 2.5, it's going to give me 15. But that's actually going to give me, now I realize I made a mistake here, so let's go back. It's going to give me 2y equals 15. because 120 divided by 16 is not going to give me 15. It's going to give me 15 halves, which is 7.5. So when you actually do 120 divided by 16 in your calculator, you're going to end up with 7.5, which is our correct answer. Which I found, again, kind of checked myself there by multiplying the numerator and denominator by 2.5. So those, well, okay, so let's do this and then we'll talk about something else. Do the ratios form a proportion? So this is another one, right? So initially I would say, well, if it cross multiplies and the cross product are equal, then my answer is a yes. All right, yes. The ratios form a proportion. Let's check out the second one. Right, do these ratios form a proportion? Well, let's see. Is 4 times 30 equal to 5 times 14? Well, no, I don't think 120 is equal to 70, so that would be no. So in other words, what I did in red on top, those are equivalent fractions. If I simplified 36 out of 60 by dividing the numerator and denominator by 12, I end up with 3/5. With the denominator, if I simplify 14 out of 30, I'm going to end up with 7 out of 15, which is obviously not the same as 4/5. Now again, this is one of those times where someone will say, well, let's take a look. From 5 to 60, I multiply 12, and from 3 to 36, I multiply 12. That's further proof that this is going to be a yes. And that same person will probably say, but look, from 5 to 30, we multiplied by 6. Which means I'd have to multiply 4 by 6, which does not give me 14, it gives me 24. So 4/5 to 24 out of 30 would be a proportion, okay? So if you want to check if something forms a proportion or not, and that's not going to be part of the homework, but it's something we should be able to do, right? Are they equivalent fractions? Now we understand. In a true proportion, the cross products are equal, so you can always cross multiply to check if two ratios form a proportion. Or if there's something missing, right, like there's a variable in one of those places, we would be able to cross multiply to solve the equation. Now this is something you should have done probably back in 6th grade, right? So it says a recipe for 8 people calls for 12 teaspoons of sugar. What if we were going to make it for 20 people? All right, so we're going to have our people, which I'll put in my numerator, and I'm going to have my teaspoons or my sugar. Okay, so let's take a look. So it says 8 people require 12 teaspoons. Now what if you had 20 people? Well, I suppose then we would need X teaspoons. So that's my proportion. So when I solve it, I do 8 times X is equal to 12 times 20, which gives me 8X is equal to 240, which gives me X is 30. Which makes sense, right? Because if we find, like, if we simplify the ratio, 8 to 12 is equal to 2 to 3. So 2 people would need 3 spoons of sugar. 20 people, you'd multiply that by 10 to get 30. So there's lots of different ways we can do this. Let's look at the second one. 900 miles would take you 4 hours. Now 7 hours goes in my denominator because that's where I have hours, right? How far would we go? Well, that's my variable. So if we want to cross multiply, you'd have 7 times 900 equals 4 times X. So we're going to divide both sides by 4, and that should give us 1,575 miles. And this should be teaspoons. Now another thing you could do here is you could find the unit rate. Right? 900 divided by 4 is 225 miles an hour. You can multiply that by 7. All right, guys. These are what I would call more of like 8th grade proportions, right? So we should learn proportional reasoning in 6th grade, definitely 7th grade, right? When you talk about proportional relationships and things like that, you spend a lot of time on proportions. So these are more what we'll call 8th grade proportions because they require us to distribute. So this is another question that I ask in class, and I say, well, how am I going to do the cross multiplication of the 15 to the x plus 5? And somebody says, well, you got to put parentheses there. And I would say, absolutely. So when we go to cross multiply, and again, you don't really need to do this. I know some of us are really used to seeing it. I don't love it, to be honest with you, so I think I'm done with that little butterfly type thing. But if you need it, by all means, you can use it. So we know I'm going to distribute here, so that's 15x plus 60 equals 3 times 45, which is 135. Now we have a pretty simple two-step equation, right? So 15x is equal to 75, so it looks like x is equal to 5. Well, what would my check look like? Well, if I rewrote my equation and then substituted, I would get this, which would then give me this. And at this point, I have a lot of different strategies, right? One thing I can do is I could simplify both fractions, and I can say 1/3 is equal to 1/3. Now, I know a lot of you guys aren't maybe, I don't want to say familiar because you've done it before, but aren't really kind of fresh on that since we did it maybe so long ago. So you can also cross multiply, and you can say, well, I know that if I did this right, my cross product should be equal, right? And of course, they will be. All right, let's take a look at the second one. All right, so I'll split this off here. So we're going to do the same thing, right, except here we're going to need two sets of parentheses, right, one on each side. So I've got 2 times x plus 5 is equal to 3 groups of 2x minus 6. So when I distribute here, it looks like I've got 2x plus 10, and here I've got 6x minus 18. I'm going to add negative 2x on both sides. So I get 10 is equal to 4x minus 18. I will add 18 on both sides. 4x equals 28. Divide both sides by 4, and I get x is equal to 7. All right, and if we check it on the left side, I'm going to end up with 2/8, which is 1/4, and on the right side, I get 3/12, which is equal to 1/4. So again, guys, the goal here, and again, these are really what we're going to focus on. The rest of the 3 over x equals 6 over 10, you guys should have really done in 6th and 7th grade. So these are really what we'll call 8th and 9th grade proportions, where we have to actually use the distributive property. So there's your now try, right? So you're going to pause your video. Okay, so I know at this point everybody worked out this problem. And you all did negative 5 times 3x minus 6 is equal to 2 times negative 10x plus 5. And I'm sure we all distributed to give us negative 15x. And I know we didn't make a mistake distributing negative 5 to negative 6, and we all put plus 30 equals negative 20x plus 10. And then it's your choice. Most of us probably eliminated the smallest variable term by adding its opposite on both sides, which is positive 20x. I'm going to add negative 30 on both sides, which should give us 5x equals negative 20. And if we divide both sides by 5, we're looking at x equals negative 4. Now what's going to happen when I check? Well, I don't have really a lot of space here to rewrite, but I'm going to have 2. Right, divided by 3 times negative 4 minus 6 equals negative 5 divided by negative 10, negative 4 plus 5. Right, so 3 times negative 4 is negative 12 minus 6 is negative 18. Negative 10 times negative 4 is 40 plus 5 is 45. So one thing you could do is you can simplify both of these fractions, and they should both give you negative 1/9. But the other thing you could do is you can cross multiply. Right? Negative 5 times negative 18 really should be the same as 2 times 45 if I did this correctly. And of course, 90 is equal to 90, confirming that x is equal to negative 4. All right, guys, there's your homework. You're going to solve and check. I'm only giving you 3 of them, so please make sure that you solve and you check for all of them, okay? So you're going to put your parentheses there. You're going to cross multiply. With number 3, it's your choice. Do you want to combine the like terms first? Do you want to do them after? I think for many of us, it's going to be better to do it after. It's easier to do it at the beginning. But I think to prevent mistakes, I would recommend some of us do it at the end. So put your parentheses there, cross multiply, distribute, then combine your like terms, and then solve the multi-step equation. As always, guys, questions, comments, concerns, upload your homework, and then post a comment on Google Classroom, and I'll get back to you as soon as I can.